Welcome back to This Week in Biochar. Ready to dive into some more of the latest and greatest biochar news from Biochar today. First up, something that really impacts global food production, salt-affected soils.
Yeah, Biochar today highlighted a new review in Applied Ecology and Environmental Research about it. It's a huge problem. We're talking over 800 million hectares of land worldwide.
Wow, that's a scary number.
It is, and when soil gets too salty, crop yields just plummet. But this research on biochar, it offers some hope.
So how does it actually help? Does it just soak up the salt like a sponge?
It's more sophisticated than that. Biochar can actually bind to those sodium ions, the ones causing all the trouble in salty soils.
Interesting. So it's like a targeted removal system.
Exactly. And at the same time, it helps make those good nutrients like potassium and magnesium more available to the plant.
A double whammy.
And it's not just theory. The review mentions field studies where rice yields increased by almost 20% in saline conditions after adding biochar.
That's a significant improvement.
Definitely. And beyond the immediate benefit to the crops, it improves the long-term health of the soil. You get more microbial activity, a more resilient ecosystem.
Plus, you're sequestering carbon, right?
Yeah.
Fighting climate change while you're at it.
Exactly. A win-win for both agriculture and the environment. But it is important to remember that there's no one-size-fits-all biochar solution.
That makes sense. So the type of biochar and how you apply it, that has to be matched to the specific soil and climate you're working with.
Precisely. Now, speaking of tailoring things to specific needs, did you see that blog post on Biochar today about energy storage?
I did, and to be honest, it really surprised me. I never thought of biochar being part of the renewable energy revolution.
It's definitely a rapidly evolving field,
Mhm.
but biochar, it has this amazing ability to be customized,
Yeah.
and that makes it a very versatile tool for energy storage.
How so? I mean, what makes biochar so special in that context?
It all boils down to pyrolysis. You heat up biomass in a low oxygen environment, and by carefully controlling that process, we can actually tweak biochar's properties, things like porosity and surface area.
So we can essentially fine-tune it to fit different energy storage needs.
Exactly. Now, I know the idea of using something like charred wood to store energy can seem a little strange.
I have to admit, I'm not entirely clear on how that works.
Think of it this way. The unique structure of biochar, it creates all these tiny nooks and crannies at a microscopic level. And these spaces, they can hold electrically charged particles, which is the basis of energy storage.
So it's less about the biochar itself holding the energy and more about it providing a framework for storage.
Exactly. It's like building a scaffolding for energy. And depending on how we modify that biochar, we can create different types of scaffolding, suitable for different applications.
The blog post mentioned something called supercapacitors. What are those exactly, and how does biochar play a role?
Supercapacitors, they're like batteries, but much faster at charging and discharging. And biochar, with its high surface area, it's a fantastic material for making electrodes for these devices.
That sounds promising. And the research seems to support it, right?
Absolutely. Just this year, Wang and colleagues, they published research showing that biochar-based supercapacitors could hold a lot of charge and last for thousands of cycles.
That's incredible. What about regular batteries, the kind we use in our phones and laptops? Can biochar help those too?
Surprisingly, yes, you wouldn't think it, but biochar can actually improve the performance of lithium-ion batteries.
Really? How so?
Soroka and their team, they did research a few years back where they added biochar made from agricultural waste to the battery electrodes.
And what did they find?
They found that the biochar actually improved the capacity of the batteries and made them last longer.
So we're not only talking about storing energy from renewables, but potentially improving the batteries we use every day. It's amazing.
It really is. And it doesn't stop there. There's even research looking at using biochar in hydrogen production. Visser and their team showed that biochar can support those nickel catalysts, making the whole process more efficient and environmentally friendly.
So it's kind of becoming a multitasker in the energy world.
It really is. But of course, there are still challenges. One of the biggest ones is scalability.
Right. We can make biochar in a lab, but how do you produce enough of it cheaply and efficiently to meet industrial demand?
Exactly. That's going to require some new thinking about pyrolysis techniques and scaling up production.
We talked about how biochar's properties can be tailored, which is great, but doesn't that also mean there's potential for inconsistency?
Absolutely. The source material and the production method, those can all lead to variations in the biochar's properties.
And that inconsistency, that could be a problem for things like energy storage, right?
Precisely. Consistency is key. We need reliable ways to produce biochar that has very specific properties, properties that meet the demands of those different applications.
So it's not just about making more biochar, it's about making the right biochar consistently.
You got it. And then there's the issue of electrical conductivity. Biochar, it has some natural conductivity, but for optimal energy storage, we need to boost that.
How are researchers tackling that?
They're experimenting with hybrid materials, combining biochar with conductive nanomaterials to give it that extra oomph.
So there's a lot of potential, but also a lot of work ahead before we see biochar really taking off in energy storage.
There is. But the research is moving fast, and the possibilities, they're really exciting. Just think, a future where our energy comes from renewable sources stored efficiently using a material like biochar.
That's a future I want to live in. But for now, let's shift gears to a problem that's been all over the news lately, PFAS pollution.
Mm.
Forever chemicals, they're calling them.
A very serious problem. They just don't break down in the environment, and they're a real threat to both human and ecological health.
Biochar Today had a review in CleanMat about this, exploring biochar as a possible solution.
Yeah, PFAS in our water sources is a major concern. Finding ways to remove them is crucial. And this review, it delves deep into how biochar can trap those contaminants.
So is it as simple as the biochar acting like a sponge and soaking them up?
It's a bit more complicated than that. The porous structure of biochar that provides a large surface area for the PFAS molecules to bind to.
Okay, so there's a lot of space for them to stick.
Exactly. But what's even more important is the surface chemistry. Biochar, it has this natural affinity for PFAS, almost like a magnet.
Wow, so they're really drawn to it. And that leads to some pretty impressive removal rates, right?
Yes. The review mentions studies that achieved almost 99.7% removal of PFAS from water using biochar.
That's incredible, almost completely gone.
It is, and researchers are pushing it even further. They're modifying biochar to make it even stickier to PFAS.
How are they doing that?
Well, there are several ways. Acid washing is one, and another is infusing the biochar with metal nanoparticles. They're essentially fine-tuning the biochar to target these contaminants even more effectively.
That's amazing. They're basically designing a biochar specifically for PFAS removal.
They are. They're even using machine learning to predict and optimize biochar's effectiveness. By analyzing huge data sets, they can figure out the best production methods and environmental conditions for maximum PFAS removal.
So they're training computers to help us make better biochar.
Precisely. It's all about using the tools we have to improve our understanding and refine our approach. But even with these great results, there are still questions to be answered.
Like what? What are some of the things we still need to figure out?
Well, once those PFAS molecules are stuck to the biochar, what happens to them? We need to understand their long-term fate and make sure they're not released back into the environment.
Right, we don't want to just shift the problem somewhere else.
Exactly. And we also need to think about the disposal of the spent biochar. We need to ensure the entire process is sustainable and doesn't create new problems down the line.
So while the initial results are promising, there's more work to do to make sure this is a truly sustainable solution.
Absolutely. Now, shifting gears from the lab to the real world, Biochar Today had a piece about a company called Mashmakes in India.
Yeah, they just expanded their facility, right?
They did. Phase 2 of their facility in the Udupi district is now the largest carbon removal facility in Asia. Pretty impressive.
14,000 tons of biochar annually. That's huge.
It is, and what I find really interesting is how they're incorporating that biochar into local agriculture.
So they're not just producing it and shipping it off somewhere. They're actually working with the farmers in the region.
Exactly. That could be a key factor in scaling up biochar use effectively.
It makes sense. It's a more localized, sustainable approach. It seems like it's having a positive impact on the community, too.
Absolutely. The article mentioned that their expansion has created jobs and contributed to economic development in the area. It's great to see a company focused on both environmental and social responsibility.
And their efforts have been recognized internationally, right?
They have. The Danish government has praised them as a model for Indo-Danish collaboration on climate goals.
So they're really setting an example for the biochar industry, showing that sustainability and innovation can go hand in hand.
Definitely. Now, for our final topic in this segment, let's talk about wastewater treatment. With water scarcity becoming more and more of a problem, sustainable solutions are more important than ever.
Absolutely. And Biochar Today highlighted a study in Water Research Journal that looked at using biochar, specifically sledge biochar, in constructed wetlands.
Interesting. Can you explain what a constructed wetland is? I'm not familiar with that.
Basically, it's a man-made wetland that's designed to mimic natural processes. Plants and microorganisms work together to clean the wastewater, removing those pollutants and releasing cleaner water.
So it's like using nature's own cleaning system.
Exactly. Pretty cool,
Yeah,
right?
it is. But those traditional constructed wetlands, they often have trouble removing nitrogen efficiently, especially when there's not enough carbon in the system.
Ah, and that's where the sludge biochar comes in.
You got it. This study by Wu Yang and colleagues, they found that using sludge biochar as an electrode material in these wetlands really boosted the nitrogen removal.
By how much?
They were able to achieve 95.85% removal efficiency. Pretty remarkable.
That is impressive. But what's even more remarkable is that they were actually generating electricity from this system at the same time.
Right. They were able to achieve a maximum power density of 9.05 milliwell or Winnowell A1. It really shows how biochar can help create these systems that are both sustainable and resource efficient.
So cleaning wastewater and producing energy all in one go. Talk about a win-win.
It really is. Now, how does this sludge biochar actually work, scientifically speaking?
Well, it's got to do with those electrochemical properties of the biochar and its ability to support all those different microorganisms.
Right. The biochar helps enhance something called denitrification, where those microorganisms convert those harmful nitrogen compounds into harmless nitrogen gas.
So it's like the biochar is giving those good bacteria a helping hand.
Exactly. And as a byproduct of that process, you get electrons released. And those electrons, they can be harnessed to generate electricity.
Amazing. So we're taking waste and turning it into something valuable. Talk about a circular economy.
Couldn't have said it better myself. This technology really highlights the potential of biochar to help us move towards a more sustainable future. Now, before we move on to the next segment, I want to touch on something important. Biochar quality. Biochar Today had a blog post about preparing biochar for soil applications, and it really stressed the importance of testing and standards.
Right, because not all biochar is created equal, is it?
Absolutely not. Making sure you're using high-quality biochar is crucial, especially when you're talking about soil health.
The blog post talked about guidelines set by the International Biochar Initiative, or IBI. What do those guidelines cover?
They're basically a framework for testing biochar and making sure it meets certain standards. It's all about ensuring that it's safe and effective to use.
Makes sense. So what kind of tests are we talking about?
Well, they have different categories. First, you got those basic properties like moisture content, pH, that kind of thing. That gives you a good starting point.
Like a basic health check for your biochar.
Exactly. Then there's a category for toxicant assessment. That's especially important for biochar that's made from processed materials. You want to make sure it doesn't have any harmful levels of heavy metals or other contaminants.
Right, you don't want to be adding anything dangerous to your soil.
Absolutely. And then there are some optional tests, more advanced ones, that look at things like nutrient availability and surface area.
So you can get a really detailed picture of your biochar's potential benefits.
Exactly. The IBI guidelines are a great resource for both producers and consumers of biochar. They help ensure that we're using this material safely and effectively.
And speaking of using it effectively, the blog post also talked about the importance of the feedstock, the material used to make the biochar.
Absolutely. The feedstock is the foundation of the whole process. It directly impacts the quality and the properties of the final biochar product.
So what kind of things should we be looking for in a feedstock?
Clean, appropriate materials are key. You want to avoid anything that could contain hazardous materials. The blog post specifically mentioned that using things like municipal solid waste is generally not a good idea.
Yeah, that makes sense. We want to keep things clean and safe.
Exactly. And another thing to keep in mind is that weathering and post-processing, those can actually affect biochar's properties. So if it's been sitting out in the elements or has undergone some kind of modification, it's important to retest it.
So even though it's a natural product, we need to be mindful of how we handle it and make sure it's still up to snuff before we use it.
Exactly. And the blog post ended with some helpful tips for using biochar, like matching the right type of biochar to your soil's needs and storing it properly to maintain its quality.
Great advice. It's a reminder that biochar is a powerful tool. But like any tool, it needs to be used correctly to get the best results.
Couldn't agree more. Biochar has so much potential to improve soil health and promote sustainable agriculture, but we need to approach its use with knowledge and care. It's a lot to take in, isn't it?
It is. We've covered so much. Salt-affected soils, energy storage, those forever chemicals, and then that company in India, Mash Makes, scaling up production, working with local farmers. It's amazing.
A lot of excitement around biochar these days. But it's important to stay grounded, too. Lots of potential, yes, but challenges as well.
Like what? What kind of challenges?
Well, take scalability, still a major hurdle for a lot of these applications. We need to figure out how to produce high-quality biochar on a much larger scale and do it cost-effectively if we want to see it widely adopted.
Right, lab scale is one thing, but industrial production is a whole other beast.
Exactly. And then there's that issue we talked about earlier, the variability of biochar.
Right, different feedstocks, different production methods, that can all lead to different properties in the final product.
And for something like energy storage, where you need consistency, that can be a real problem.
So standardization is key.
Absolutely. Reliable methods for producing biochar with specific properties, that's essential. We need to be able to consistently produce biochar that meets the demands of each application.
Otherwise, it's like trying to build a house with bricks of all different shapes and sizes. It's not going to work very well.
Perfect analogy. And of course, we can't forget about the environmental impact of biochar production.
Right, we don't want to solve one environmental problem by creating another.
Exactly. Life cycle assessments are so important. We need to look at the whole picture, from the source of the biomass to the energy used in pyrolysis and all the potential emissions.
So it's about making sure that the overall environmental footprint is positive.
Precisely. You know, it's interesting, as we talk about all these different biochar applications, I'm struck by how interconnected they all are.
In what way?
Well, we've got soil health, energy storage, water treatment, carbon sequestration. They all seem like separate issues, but they're not really.
I see what you mean. They're all part of the same big challenge, creating a more sustainable and resilient future.
Exactly. Biochar isn't a solution for just one problem. It's a tool that can help us address multiple challenges at the same time. And those challenges, they're all intertwined.
Like a web, you pull on one strand and it affects everything else.
Right. It's a systems thinking approach. And biochar, it fits right into that. It's a bridge between science and sustainability, connecting cutting-edge research with real-world solutions.
That blog post about biochar quality, that keeps coming back to mind. They really emphasize the importance of testing and standards, like those IBI guidelines.
It's all about quality assurance. We need to make sure that the biochar we're using is safe, effective, and sustainably produced. Those IBI guidelines, they provide a framework for testing and evaluating biochar's properties, so we know how it's going to behave in different applications.
It's like a recipe. If you want to bake a cake, you need the right ingredients in the right amounts. Same with biochar. The right feedstocks, the right production methods, and testing to verify the final product.
And that builds trust, too. Consumers need to know that the biochar they're buying is high quality. It's essential for the growth of the industry.
What's also interesting is that, just like with cooking, there's no one-size-fits-all approach to biochar. Different applications will require different types of biochar with specific properties.
Absolutely. That's where those IBI testing categories come in handy. They help us understand the nuances of biochar and match the right product to the right job, whether it's improving soil or filtering water or making better batteries.
It's about being informed, being thoughtful about how we use this material.
Exactly. And as the research continues, we're going to see even more specialized biochar products tailored for very specific purposes. It's an exciting time to be following this field.
Now let's get back to energy storage for a bit. I'm still amazed by how biochar, something as simple as charred biomass, can be used in such high-tech applications.
It really is quite remarkable. Supercapacitors, batteries, even hydrogen production, biochar is showing potential in all these areas. But there's still work to be done, especially when it comes to scaling things up.
Right, going from the lab to large-scale production, that's a big leap.
It is. And we need to make sure it's cost-effective, too. Plus, there are potential environmental concerns that need to be addressed.
And we need to keep learning. There's still so much we don't know about how biochar behaves in these complex systems.
Absolutely. More research is needed to understand those long-term effects, how biochar interacts with other materials, how its properties change over time. We need to optimize its performance for each specific application.
But the possibilities, they're really exciting. Imagine a future where our homes are powered by renewable energy stored in devices made with biochar.
It's a vision worth striving for. And it's not just about the technology itself, it's about creating a more sustainable and resilient energy system.
A system that benefits everyone, not just a select few.
Exactly. Moving away from fossil fuels towards a more decentralized, democratized energy future. And biochar could play a key role in that transition. But it's going to take a collective effort. Scientists, engineers, entrepreneurs, policymakers, all working together.
It's a big challenge, but it's one we need to tackle. Now let's shift gears back to PFAS pollution. Those forever chemicals, they're a sobering reminder of the impact we're having on the environment.
PFAS contamination is a serious problem, and finding effective solutions, sustainable solutions, that's crucial. And biochar, it's emerging as a promising tool in that fight.
Those studies showing biochar's ability to remove PFAS from water, those were really encouraging, almost 100% removal in some cases.
It's impressive, isn't it? That porous structure, the unique surface chemistry, it's like biochar is specifically designed to trap those pollutants.
And researchers are finding ways to make it even better, those modifications we talked about, the acid washing, the metal nanoparticles, they're really pushing the boundaries.
They are, and using machine learning to optimize the process, that's really exciting.
It's amazing what we can do with technology these days. But even with all these advances, we still need to be cautious, right? We need to think about the long-term implications.
Absolutely. What happens to those PFAS molecules once they're stuck to the biochar? Where do they end up? Are there any risks associated with disposal? Those are questions that need answers.
Right. We don't want to create unintended consequences down the line.
We need to make sure the whole process is sustainable from start to finish. Responsible implementation, that's key. And it all comes back to that systems thinking approach we were talking about earlier.
We can't solve these problems in isolation. Everything is connected.
Exactly. Sustainability, it's about understanding those connections, understanding how our actions impact the whole system, and finding solutions that create a ripple effect of positive change.
Speaking of positive change, that story about mash makes, that was really inspiring. They're proving that sustainable practices can be good for business and good for the community.
They're a great example of how sustainability and economic growth can go hand in hand. And the recognition they're getting internationally, that just shows the impact they're having.
They're setting a high bar for the biochar industry.
They are. Now, for our last deep dive, let's go back to wastewater treatment. Those constructed wetlands using sludge biochar, that's such an elegant solution, don't you think?
It is. Using nature's own processes to clean our water, it's brilliant.
It's a great example of biomimicry. Those constructed wetlands, they're designed to mimic natural wetlands. Plants and microorganisms working together to remove pollutants, releasing cleaner water back into the environment.
It's amazing how effective it is. But you said earlier that they sometimes struggle with nitrogen removal.
They do, especially when there's not enough carbon available. And that's where sludge biochar comes in. It boosts that nitrogen removal, and on top of that, it allows the system to generate electricity.
Like a superhero, saving the day in multiple ways.
Exactly. That study we talked about, they achieved over 95% nitrogen removal efficiency, and they were able to generate electricity at the same time.
It's a win-win situation, both environmentally and economically.
It really is, and the science behind it is fascinating. The sludge biochar enhances that denitrification process, the one where microorganisms convert those harmful nitrogen compounds into harmless nitrogen gas.
So it's helping those good bacteria do their job?
Exactly. And as a byproduct, you get those electrons released, which can be used to generate electricity.
It's like closing the loop, turning waste into a valuable resource.
Exactly. This technology has huge potential to revolutionize wastewater treatment, and it's exciting to see it gaining momentum.
As we wrap up this segment, I want to leave our listeners with something to think about. We've seen how biochar can be used to revitalize soils, clean water, even power our homes. It's a versatile material with seemingly endless possibilities.
But the big question is, where do we go from here? How do we take all this potential and turn it into a reality? How do we create a more sustainable future with biochar?
That's a big question, and I don't think there's one simple answer. But I think it starts with continuing the research, pushing the boundaries of innovation, working together to find solutions that are both practical and inspiring.
I couldn't agree more. We need to keep exploring the possibilities, keep learning, keep pushing the boundaries of what's possible with biochar, and we need to do it responsibly with a deep understanding of the interconnectedness of all things.
It's about finding that balance between scientific advancement and environmental stewardship, creating a future where both people and the planet can thrive.
Well said. It's about finding those solutions that are not just good for us, but good for the whole web of life.
Now, we've got one more fascinating biochar development to discuss before we wrap up today's episode. So stay tuned for the final segment of This Week in Biochar. Welcome back to This Week in Biochar. For our final segment, we're going to shift gears a bit. We've talked about all these high-tech applications, but now I want to get back to basics, specifically soil health.
Back to the roots, so to speak.
Exactly. Biochar today had this great blog post, the Soil Ready Checklist on how to prepare your biochar. It really got me thinking about how important it is to use biochar correctly, especially when it comes to soil.
It's a good point. With all this excitement about biochar, it's easy to forget the practical side of things. Not all biochar is the same. And if you want to get those benefits, you need to know how to prepare it, how to apply it correctly.
The blog post highlighted those IBI testing guidelines. We touched on them earlier, but maybe we can dive a little deeper.
Definitely worth a closer look. The International Biochar Initiative, they've created this really comprehensive framework for testing biochar. Everything from basic properties to potential contaminants. It's a great resource for anyone involved in biochar, producers, consumers, everyone.
Can you remind me what those different categories of tests are? I remember there were a few.
Sure, so first up, you've got the basic utility properties. These tests look at things like moisture content, how much organic carbon is there, the pH level, the electrical conductivity. Basically, they give you a fundamental understanding of how that biochar is going to interact with the soil.
So it's like a checkup for your biochar, making sure it's healthy.
Exactly. Then there's the toxicant assessment category. This is really important, especially for biochar made from those processed feedstocks. You want to be absolutely sure that there aren't any harmful levels of heavy metals or other contaminants.
Right, you don't want to be adding anything toxic to your soil.
Exactly. And then there's the advanced analysis category. This one's optional, but it goes deeper into the biochar's properties, things like nutrient availability and surface area.
So if you really want to geek out on the details, those are the tests to go for.
Precisely. By understanding these testing categories, you can make sure you're choosing the right biochar for your needs and using it safely and effectively.
The blog post also mentioned how important the feedstock is, the material used to make the biochar. They said it should be free of hazardous materials, and they specifically said to avoid things like municipal solid waste.
Makes sense. The feedstock is the starting point. If you start with something contaminated, that contamination is going to carry through to the final product.
So it's all about choosing clean, appropriate materials from the get-go.
Absolutely. And they also pointed out that weathering, being exposed to the elements, that can affect the biochar. And so can any post-processing modifications. So if your biochar has been sitting around for a while or has been treated in some way, it's a good idea to retest it.
Even though it's a natural product, we need to be mindful of how we handle it and how it might change over time.
Exactly. And the blog post wrapped up with some great advice about using biochar. Things like making sure you're using the right type of biochar for your soil and storing it properly so it doesn't degrade.
Good practical tips. Biochar is a powerful tool, but you need to know how to use it correctly.
Couldn't agree more. It's all about maximizing those benefits and minimizing any potential risks. When used correctly, biochar can really make a difference for soil health and sustainable agriculture.
Well, this has been an incredible journey through the world of biochar. We've covered so much ground, from improving our soils and cleaning our water to powering our homes and fighting climate change.
Biochar really does seem to have a solution for almost every challenge we face.
It's incredible how versatile this material is, and the most exciting thing is we're just scratching the surface. There's so much more to discover.
With all the research and innovation happening, who knows what the future holds for biochar? But I have a feeling it's going to be amazing.
I think so too. Biochar shows us that we can use nature's wisdom to solve some of our biggest problems. It's a glimpse into a future where human ingenuity and the natural world work together to create a better world.
A more sustainable, equitable world for all, and it's a reminder that sometimes the solutions are right in front of us waiting to be discovered.
That's a great note to end on. Thank you for joining us for this deep dive into This Week in Biochar. We hope you learned something new and are as excited about the future of biochar as we are. Until next time, keep exploring and keep learning.